1.5, solving equations with variables on both sides. So up to this point, every equation we have seen has only had variables on one side of the equation or the other. Does everyone agree with that statement? We've never seen variables on both sides of the equal sign, have we?
No.
Well, we're going to have to deal with those at some point, so might as well be today. So from here on out, there's a chance that there could be variables on both sides of our equations. To solve an equation with variables on both sides, simplify one or both sides of the equation if necessary. We've already kind of done that, haven't we? Distributive property, combining like terms, we've already simplified if necessary before. We still need to do that whenever we're solving equations with variables on both sides. Then use the inverse operations to collect the variable terms on one side. Okay? So I want to get all my variables to the same side of the equation, and we'd still do that using our inverse operations. Inverse of addition is subtraction. Inverse of subtraction is addition. Inverse of multiplication is division. And inverse of division is multiplication. After we collect the variable terms to one side, we then want to collect the constant terms on the other side. So we get my variables to one side. Do we know what a constant term is?
No.
A constant is a number without a variable. Okay? So after we get our variables to one side, we want to get all our terms without a variable to the other side of the equation, and then solve for our variable. Isolate the variable like we have in the past. So what does it tell me to do first, besides simplifying, after simplifying? Does it tell me to move the constants first or the variables first? Variables first, okay? Always, always, always collect your variables to one side first, and then your constants. Okay, and I'll show you why towards the end of our notes. Everyone got me? Okay, can I move on?
You don't want to sort that down, do you?
You can if you wanted to. You don't have to necessarily. These are your notes. Solve each equation, check your solution. 10 minus 4x equals negative 9x. 10 minus 4x equals negative 9x. So over here, what's the very first step I need to do?
You got to switch to 9x with the 10.
What's the very first sentence?
Oh, solve the equation with variables.
To solve an equation with variables on both sides.
Simplify one or both sides of the equation if necessary.
Okay. Is there any simplifying that can be done on the left side of my equation? Any combining like terms, distributive property, anything like that?
No.
Okay. On the right side, is there any simplifying I can do?
No.
No. So is that first step necessary on this case?
No.
No. Okay. After I simplified one or both sides, what does it tell me to do?
Do inverse operation.
To
To collect the variable terms on one side.
collect the variable terms on one side. So I've got an x on the left and I've got an x on the right. I want them on the same side of the equation. Can anyone tell me how I'm going to do that?
You're going to switch out to 9.
Oh wait, I think I know.
What?
You do like that. You do the add 4x.
Yeah.
Take it.
Trying to get our variables to one side. It doesn't matter which variable I move. I can move either variable I want to. Jake said, let's move the 4x over here by adding 4x to both sides. And it'll cancel out on the left. Okay? Once again, whatever I do to the left, I have to do to the right side as well. So what do I have left on the left-hand side after my 4x is canceled? 5x. They're canceled right here. What do I have left on the left?
Oh,
10.
Oh, 10. Yeah. My bad.
Now, what's negative 9x plus 4x? Negative 5x. Any questions about that first step? I got my variables to the same side of the equation. They're like terms, so I was able to combine them. Now I just got one variable. What does my next step tell me to do? Yeah, collect the constant terms on the other side. Well, when I did my first step, that already did that second step for me, right? My constant terms are on the opposite side of the equation as the variable, aren't they? Remember, a constant's a number without a variable. Everyone see that? So I don't need to do anything else to move at 10, do I? Okay. After I collect my constant terms to the other side, well, now what do I need to do? Isolate the variable. This just becomes an equation that we've dealt with in the past. Okay, how would I get x by itself if it's being multiplied by negative 5? Divide by negative 5. 10 divided by negative 5 gives me negative 2. I have now solved for my variable. Questions about that? It does tell me to check my solution, so I do need to check it. I need to see this on your work if it tells you to check your solution. So where am I plugging the negative 2 in?
Everywhere the x is.
Which x?
Both x's?
Both of them. I got to plug it in for both x's. So I take the x out, replace it with negative 2. Take the x out, replace it with negative 2. And then I work down both sides of my equation using my order of operations. So on the left, do I do subtraction or multiplication first? Multiplication. What's negative 4 times negative 2?
Negative 8.
Negative 4 times negative 2.
Negative 8.
Negative 4 times negative 2.
Negative 4 times
No, 8.
Positive 8. Negative 9 times negative 2.
18.
18. And then what's 10 plus 8?
18.
18. Do I get a true or false statement?
Sure.
True. So I know my answer of negative 2 checks out. Any questions on number 1 here? How I feel about it? Pretty good. Okay, can I erase my work of checking my solution so I can do number 2 now? Can I erase it?
Yes.
Okay, number 2. Negative 2x equals 3x plus 10. Raise your hand if you can give me my first step. Yep.
Simplify both sides if necessary.
Okay. Can I simplify the left side at all?
No.
No. Can I simplify the right side at all? No. So check. Done.
Can you do the negative 3x and then bring it over to the
Yeah. So I would do what to both sides?
negative 3x?
Subtract 3x. So it'll cancel on the right. Whatever I do to the right, got to do to the left. What's negative 2x minus 3x?
Negative 5x.
Negative 5x. I'm left with 10 on the right. And how do I get x by itself?
Oh, we do the same thing.
Yep. Turns out to be the same problem, essentially. Different numbers to begin with. Any questions on number 2? Do you guys need to see me plug in and check my solution, or are we good with that? I can do it if I need to.
Oh, wait, no.
Huh? You don't need to see me do it? Anyone need to see me do it? I can do it.
No.
Okay. Questions on examples 1 and 2? Can I move on? All right. Okay, solve each equation. A little bit more difficult examples. Not terrible, though. We can handle it. Number 1, I've got 3 times 3x minus 4 equals 1/4 times 32x plus 56. Not terrible. Just some fractions thrown in there, and it's okay. We're fine. What do I need to do first here? Distribute, yeah. Simplify one or both sides of my equation, right? So on the left, do I need to distribute?
Yes.
Yep, multiply my 3 all the way through the set of parentheses. What's 3 times 3x?
9x.
9x. And 3 times negative 4?
Negative 12.
Negative 12. We okay with my left side? Okay, what do I need to do with my right side? Distribute the 1/4 through my parentheses. What's 1/4 times 32x?
16?
No.
Oh, shoot. Oh, it's 1/4. I wrote it down 1/2.
What's 1/4?
Okay. Yeah, that's.
If it was 1/2, it would be 16, yes. But 1/4 would be 8x. 1/4 times 56? 14. We okay with my distributive property? Am I moving too fast for anybody?
No.
Okay. Can I simplify the left side anymore?
No.
9x minus 12?
No.
No. Can I simplify my right side anymore? 8x plus 14? No. So I've done all the simplifying I can do on both sides. What's my next step?
Doing the inverse, not inverse operation.
Inverse operations to do what though?
Flip the. I forgot what the thing said.
Yeah, to collect my variable terms to one side of the equation.
Yeah.
So what do I need to do to both sides of the equation in order to do that?
Combine the variables.
Well, yeah, how?
But you could-
What operations am I doing?
-9x or -8x.
Which one do you want to do? Subtract x from both sides?
It doesn't matter.
Doesn't matter.
Okay.
I can move either variable to either side of the equation. As long as I get all my variables to one side of the equation, I'll be good. I'm going to get the same answer either way. Okay? Everyone okay with that?
Yes.
What's 9x minus 8x? X. I still have the minus 12 on the left and equals 14 on the right.
So you do.
Any questions on this step right here? We following?
Yes.
Any confusion that I need to clear up? Simplified both sides of the equation. I now have my variables to one side of the equation. Now what do I need to do?
Oh, dude, the +12.
Yeah, I got to get my constant terms to the opposite side of the equation for my variables, right? So I've got a minus 12 over here, 14 over here. My variable's on the left, so where do my constant terms need to be?
On the right.
On the right. So what do we say to do?
Add 12.
Add 12. So what does x equal? 26. Isolate the variable. Variable's already by itself, so there's my answer. Questions on number 1. Do you need to see me plug in on this problem to check my solution? Actually, does it tell me to check my solution? No, so we don't need to. Questions on 1? All right. Number 2. Very similar problem, just different numbers. What do I need to do first? Distribute. Got to do my negative 3/4 through the set of parentheses. Negative 3/4 times 8n would give me what?
-6.
Negative 6n. Negative 3/4 times 12. Huh? Negative 9, yeah. We okay with my left side after distributive property? Okay, on the right side, what do I need to do? Distribute the 3. 3 times n. 3n. 3 times negative 3. Negative 9. Any questions on my right-hand side after the distributive property? I feel like we're all good with distributive property. Am I correct in saying that? We all understand how to use it? Okay. Can I do any more simplifying on the left? No. Any more simplifying on the right?
No.
No. So now I need to start doing what? Getting what to one side of the equation?
The variables.
Variables. I want to move my variables first, right? Not my constants. Move my variables first. So once again, it doesn't matter. I can move the negative 6 in to the right, or I can move the 3 in to the left. What do you guys want to do? Move the 3 in. So how would I get rid of the 3 in on the right?
Negative 3.
Yeah. Subtract 3 in, because it's a positive 3 in. That way it'll cancel over here. Whatever I do to the right, got to do to the left. What's negative 6 in minus 3 in? Negative 9 in minus 9 equals negative 9. Make sure that minus sign stays with the 9. It makes it negative, so it has to stay with it. It's a lot of 9s. Okay, I got my variables to one side. What do I need to do with my constants? Get them to the other side, the opposite side of the variable, right? So how do I move that minus 9 over? Add 9 to both sides. Move my work up yonder. Left with negative 9 in on the left. What's negative 9 plus 9? 0. That's okay. We can have 0. 0 is a number, right? Some of you guys see 0 and you're like, crap, I did something wrong. You can have 0. Now how do I get in by itself? Divide by? Negative 9. 0 divided by negative 9? 0. My answer is 0. Questions on 2? Are we still tracking? Just follow those steps that were on that first slide we had. Simplify one or both sides of the equation first. Then get your variables to one side of the equation. Then get your constants to the opposite side. Then isolate the variable. Do we have any questions on these two? Can I move on? Okay. Every equation that we've had up to this point has had one solution. Do you guys agree with that statement? A variable equals some number, right? That's just one solution. Equations do not always have one solution. An equation that is true for all values of the variable is what we call an identity and has infinitely many solutions. That means any number I plug in will work for that equation. Okay? We have equations that are like that. An equation that is not true for any value of the variable has no solution. That means any number I pick to plug in, no number will ever work. There's not a number that will work for that equation. Okay? Does that make sense? So we're going to see some examples of those on the coming slides. Can I move on to those, or are we still writing this down? I guess I can move on. Okay, solve each equation. 3 times 5x plus 2 equals 15x. 3 times 5x plus 2 equals 15x. We know this is probably going to be one of our special solutions, but we still try to solve it like any normal equation. Okay? Simplify one or both sides, get the variables to one side, get the constants to the other, isolate the variable. So what would be my first step here on letter A?
What's that thing called?
What? Yeah, distribute. I know that's what you were looking for. Distribute the 3 through the set of parentheses. What's 3 times 5x? 15x. 3 times 2? 6. Can I do any simplifying on the right? No. Can I do any more simplifying on the left? No. So I've simplified one or both sides of the equation. Okay, do we move the variable first or the constant first? Variable. These special solutions are why we move the variable first, and let's see why that is the case. How would I get the variables to the same side of the equation here?
You have to do the negative 15.
Subtract what?
15.
15x from both sides.
Not bad again.
What happens?
It turns to 0.
Yeah, it cancels out on both sides of the equation, right? It's 15x minus 15x equals 0x, or 0.
So So we just
So what's left on the right after the 15x is canceled?
nothing.
Or the left, I mean.
6.
6. Is there anything left on the right-hand side?
No.
What number do we represent nothing?
0.
0. Okay.
That's
So,
the answer.
whenever I have my variables cancel each other completely out on both sides of the equation, I have to look at the statement that's left over. 6 equals 0. Is that true or false?
False.
False. 6 does not equal 0. So do you think this is infinitely many solutions or no solution?
No solution.
No solution. So you can write out no solution, or you can use our no solution symbol, which is a 0 with a slash through it. Circle with a slash. Does everyone see that?
Yes.
That means any number I pick to plug in here, no number will ever work. It has no solution whatsoever. You can test it all day long. No number will ever work for this equation. If you don't believe me, you guys want to pick a number?
63.
63. Okay. What's 63 times 5?
63 times 5.
Yep.
63 times 5 equals 315.
Equals what?
315.
315. What's 315 plus 2?
317.
317. What's 317 times 3? 951. Okay, that's the left-hand side of the equation. What's 15 times 65?
65.
Is that what we picked? 65.
Yeah, 63.
63. 15 times 63. My bad.
945.
Yeah,
945. Is that true or false?
False.
False. That number doesn't work, right? It's not a solution. Any number you pick, you're going to get a false statement when you plug it in.
Where are you putting?
I plugged it in for x. Just like checking my solution, right?
Yeah.
So, there's no solution, no number will ever make this equation true. Okay? Does that make sense?
Yes.
We figured that out because variables cancel each other completely out. I'm left with a false statement, no solution. Okay? This is why we move the variable first. Okay? That way I can see if my variables cancel each other completely out, I can look at my statement that's left over.
So then, would we even have to solve out the entire equation? We can just look at the problem and see that the variables have the same constant with them, and just automatically realize 15x is on one side, 15x is on the other side. So that just means there's no solution.
I still want you to carry it out because the same thing's going to happen here soon, but we're going to get a different answer besides no solution. So you got to get to the final statement that's left over to decide if it's no solution or infinitely many solutions. Okay? So let's look at letter B. Once you do get the same number with the variable, you probably know it's probably going to be one of those two, but we got to carry it out to see which one it's going to be. So what's my first step on letter B here? Distributive property. Negative 2 times 4y. Negative 8y. Negative 2 times 1. Negative 2. Have negative 8y minus 2 on the right. Can I do any more simplifying on either side?
No.
So like Nolan was saying, hey, I've got a negative 8y on the left and I've got a negative 8y on the right. They're going to cancel out, but we need to see what's going to happen here, okay?
Wouldn't it be in,
It's in.
yeah, it wouldn't be a solution.
Well, hold on. Let's finish. Let's keep going like we're solving this equation. How do I get the variables to the same side here?
You do the negative 2 to 1 each side.
No,
Or I mean
because-
positive 2, that's what I meant.
Do I move the constant or the variable
No,
first?
It's the negative 8y first.
Oh, yeah, my bad. Yep.
I need to add 8y to both sides. But, like we already said, we know it's going to cancel out. What's left on the left-hand side now?
Negative 2.
Negative 2. What's left on the right?
Negative 2.
Negative 2. Okay, so over here, variables canceled out. I was left with a false statement, so it was no solution. No number will ever work for this equation. Okay? Is this a true or false statement? True. So how many solutions do I have?
Infinite.
Infinitely many. So I want you to either write it out. Infinitely. And make sure you spell it right. I'll put it up here for you. Infinitely many solutions, either write that out. I'm okay. If you put IMS, I'm fine with that. Please, 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 however, do not use the infinity symbol. My answer is not infinity. I have infinitely many solutions. So either write it out or write IMS. Okay? Do not do that. My answer is not infinity. And don't put the infinity symbol, MS, or infinity symbol many solutions, just either this or this. Okay? So, what this means is any number I pick to plug into this equation will make my equation true. All real numbers are going to work for this equation. You can pick a number if you want. If you don't believe me, test it out, plug it in, check your solution. You should get a true statement out of it. Okay? Any questions on A or B here? How do we feel about the no solution, infinitely many solutions? You're only going to get these two options if your variables cancel each other completely out on both sides. False statement, no solution. True statement, infinitely many. If your variables don't cancel each other completely out, you're going to get one solution. Variable equals some number. Okay? Questions on that? Here's just a quick overview of just solving all of our linear equations. The ones we solved last week and the week before that. The ones we're solving today. Here are several steps you can use to solve a linear equation. Depending on the equation, you may not need to use some steps. So step 1 is use the distributive property to remove any grouping symbols. We may not always have distributive property, so we would just skip that step. Step 2, simplify the expression on each side of the equation. That may be already done for us, so we may not need to do step 2. Collect the variable terms on one side of the equation and the constant terms on the other. I would write these down if I were you guys.
Can we take a picture?
Just go ahead and write it. Well, just go ahead and write it down. Step 4, isolate the variable. Step 5, check your solution. We can use these steps to solve any of our equations, our linear equations. Like it says, though, you may not need to use every step every single time. But I would definitely have this written down if I were you guys. That means pick up your pencil and write it on your notes. Yeah. I'll give you time to write it. We're pretty close to finishing. What step are we on? 4? Pretty close. Done writing these steps down? Okay. Here's your assignment for the day. Page 35, numbers 4 through 26, evens. 4 through 26, evens.
Of the book.
Yep. It's like 12-ish problems, I think. So, this is our assignment. This will be due Wednesday, August 31st on Canvas.
That's only one day.
So that is in your textbook. You have textbooks under your chairs. You have access to the textbook on your computers. If you need to, you can take a picture of the book page before you leave. That way, if you want to use it that way, I'm fine with that. But are there any questions about my notes before I end my recording? All right.